Hey everyone, welcome back to Programming with Amir. Today we're going to talk about something that looks simple in code, but has an entire world of logics underneath. You've probably seen this line before, and maybe you thought that's it, but inside this line lies the process that makes computer learn. Let's take a closer look. Okay, so I'm gonna make a new file. Just don't mind the file name, because it's something related to neurons and how they work. I have made a video back then that covers what neurons are and what they do, but in this video we're gonna see a real world example and how you can use it. Okay, so you first write model.fit x, y, and then I don't know how to pronounce this, but it's something like that 50. Okay, so you might see some errors on your screen because model fit, you don't have the variables x and y, but if you don't want to see them, you can model equal none, and then x equals none, like that. So you can see once you give them a value, they might not have any value, but they at least will have a variable to their name, so you won't have any errors. Okay, this is the moment your neural network begins to learn. One word model, one function fit. It looks simple, but it represents the entire training process behind it. Thousands of mathematical operations take place in a fraction of a second. Can you believe that? A fraction of a second. Okay, so let me go over here, and then besides this model, none, I'm gonna actually make some room, and I'm gonna come model equal this sequential that dense. So these are, I'm not making any models right now, so it might not work. I'm just explaining what each line of code maybe in your project will do. So don't think that I'm gonna go and create a model. So some of these codes are gonna give errors, like dense and sequential are gonna give errors because I haven't imported anything yet. So when we go to dense, we can give a variable 8 and then activation equals, I'm gonna choose relu, but you have other stuff you can choose from because relu is good for short stuff, and I'm just gonna choose that, and it's the one that many people know. It's the most widely used activation function. So yeah, so input shape, I'm gonna make it 4, and then I'm gonna come this, and then I'm gonna go to dense again, and then I'm gonna go 3 is good, and then I'm gonna go to activation again, and then I'm gonna do the what do you call it, another activation, but this time I'm gonna do softmax. You can choose softmax. I think sigmoid is also in here too, but I'm not too sure. Here's where the model is defined. The first line, dense 8 activation relu, creates 8 neurons. Each one of them receives an input, performs calculations, and passes a signal forward. The second line, dense 3 activation equals softmax. This is our output layer. 3 neurons, one each for flower type in the iris data. Okay? In the iris data, anything that your model you're creating. Okay, So activation is like every neuron has a function, a rule that decides whether it should fire or stay quiet. And when I mean fire, I'm not mean like kicking out like the neurons. So like you might have like a gigantic bowl, okay? But like there's some stuff you don't like and there's some stuff maybe, so think of it as like a server. You basically like you want to run a project, but like the user load is unexpectedly high. So besides the project just crashing because of the user load, what you can do is the neurons will see, okay, this process can like have like 5 neurons working on it because maybe it's like that's good for them. It's not hard for like 4 or 3. So like then that's what happens with the neurons. It will go choose like how many is ideal for the process amount, not exceeding and not minimum. So then like your model can be as accurate as it can and not use a lot of processing power, or be less accurate but use almost 0 to none. And so yeah. So yeah. So these are the 2 major things that you might see in maybe like your code or like your project. And yeah, so that's basically it for today. So you guys now learned what like the activation process is and what it does. That's basically like the whole thing of neurons. It's basically seeing like how much processing powers, because like maybe your head calculates like 40,000 thoughts a second. If all of that goes to one thought, then you can't think properly. So it will compromise each other, and then you can like, what do you call it? Then you can think of it as multitasking with the models. So that's it for today. In the next video, we will be diving deeper into like the layers of neurons and more stuff. And I hope we can create a model together. So that's it. Peace.